This summer just started, I finished all of my exams. I want to use this to make my biggest project yet. I've been hyping it up in the background of my videos, and it's a robot dog. I have only a single goal. I want to be able to take the robot dog off my shelf, turn it on and just start playing with it. I also want the robot to be able to moonwalk, but that's kind of obvious. The robot should be small and easy to iterate on. I don't want something huge that takes a whole day to reprint. If I want to change the leg design, I want to be able to do that quite quickly. It should also be very light. Which brings me to my first design choice. I'm gonna make the whole robot out of carbon fiber tubes. For the motors, I want the robot to be on the cheaper side. If you buy brushless DC motors, even the controllers are $50. It's a huge step up. I'm gonna go that way in my future projects, but this robot is gonna use servo motors. And the biggest difference between this robotic dog and the hexapod is gonna be the microcontroller. I'm gonna use ESP32. This is like an Arduino, but it has a higher frequency, so the code runs faster. And it has a built-in wireless communication. It uses ESP now, so this should fix the wireless communication issues. Now let's get into the main stuff, which is the features of this robot. If I manage to fulfill my main goal and the robot is gonna work, I want it to be able to jump. I don't know if it's possible with these servo motors. I'm gonna buy the best servos I can find. But if it is possible, that would be very cool. Another thing, which I'm not sure if I'm gonna go that way, is compliance. So if you have servo motors like these, if you smash them into the ground, they're just gonna break. And if you have a compliant robot, it has kind of springy legs, so even if the robot falls, the legs just dampen the impact. I thought about adding some kind of compliance system which would make the robots less likely to break. But I'm not sure if I'm gonna add that because I thought about it and it would be a huge pain to implement this. It would be cool if the robot could walk upstairs. I forgot to mention this, but since my latest progress with reinforcement learning, I want to implement that as well. The first step is gonna be building a single leg. I'm still not sure which motors I need to buy and how much the robot is going to weigh. So I'm going to do some quick tests to figure that out. It's been about 6 months since I last touched these ESP32s. Through ESP now, I'm wirelessly sending the value of 420 from the transmitter to the receiver. If you look at the time steps, they keep increasing. And this means it's actually receiving the values. This might look like the most boring test ever, but this is everything to me. Last year, when I was building this fucker, I spent about 8 months on the wireless communication, and it was the main reason I retired the robot. The main question I have right now is how much is the robot going to weigh? I'm going to use servo motors similar to these. Each one weighs 70 grams. The robot is going to have 12 degrees of freedom, so that's 12 times 70 grams, 850 grams. The second heaviest thing is probably going to be the battery. I want the robot to be really light, so I might use a small one like this. And this is just above 100 grams. So that's the main components. This ESP is going to weigh nothing, 10 grams, I'm not going to even count that. For the legs and even for the body, I want this to be super lightweight, so I'm gonna use these carbon fiber tubes. This is 500 millimeters and it weighs 23 grams. So this is also nothing. I might use, I don't know, 3 of these. So that's gonna be 75 grams for all of the carbon fiber parts. The main parts weigh about a kilogram. There's obviously going to be more parts, some 3D printed parts, etc. So I'm gonna shoot for 1.5 kilograms. By the way, this whole Robot Dog series is gonna be sponsored by PCBWay. I'm gonna use PCB for a controller and for the Robot Dog itself. I've used PCBWay for my hexapod robot and they turned out great. But they don't just do PCBs. If you need CNC machining, like milling or turning, they got you covered. They also do PCB assembly where they solder your PCBs for you. And if you click the link in the description, you will get a $5 discount for your first order. These tests might look pretty fucking stupid. I just want to make sure that everything is alright. I got this 2.5 kilogram weight. The leg of the robot is gonna be 25 centimeters at the longest. I can put the whole weight, 2.5 kilograms on it, and it holds it with no problems. So these tubes are strong enough, and I think I can go even smaller. They are also pretty stiff, so that's not gonna be an issue, I think. Since I've read that the torques of these servo motors are wrong, I want to measure the actual torque, so I'm printing an adapter which will attach this servo arm to the carbon fiber tube, and then I'm gonna measure the torque with this weight. While it's getting printed, I'm charging this new battery and also watching Dr. House, of course.
And it's the 21st century. You got flying cars, robot dogs.
I gotta say, this is an elegant design. So it's printed as a single part like this. From the bottom, you can use bolts to mount it to the servo arm, and from the sides, you can clamp the tube. Okay, this is quite a tight fit. This is not going anywhere. I also made this first try. This doesn't happen too often. Now I'm going to write a code for the servo motor. I almost have that completed, and then we can test out the torque. By the way, I'm testing two things with this. So first the motor's torque, and then if the code on the ESP works similar to the code on the Arduino. So there's a few differences between Arduino and ESP. One of them being that ESP has 3.3 volt logic. So this should generate a 3.3 volt PWM signal. And I want to test if this signal works on the servo motors too. Okay, so I'm gonna power the ESP and turn on the servo. Fuck. Look at this circuit and try to guess where I made the mistake. So I get the power, it's connected through a switch to the servo motor, and then from the ESP I just have a digital cable with the PWM signal. I forgot to connect the grounds. So the ESP ground and the battery's ground are different, and that's why it doesn't work. You need to connect the grounds so the voltage reference is correct. Very nice. Okay, the motors should have a torque of 45 kilogram centimeters at 6.8 volts. If we assume 900 grams, that's 0.9 kilograms times 50, 45 kg centimeters. Very nice. I have a lot more trust in these motors after these tests. I've measured the motor's torque, so I might as well measure its speed. Okay. It should take 0.51 seconds for 180 degrees, and it takes only, so this is 30 seconds, and then it's 30.45. So it takes 0.35 seconds for it to turn. I assume this is because of the high voltage, so I'm powering it with almost 8 volts, and it should be just under 7 volts. Since I knew the speed and torque of the motor, I couldn't resist calculating how high the robot can jump. If you want to see that, you can check on my second channel. But now let's move on to ordering the actual parts for the robot. I ordered these servo motors, so the brand is called DS Servo, and I got DS3230, the Pro version. It does 0.09 seconds per 60 degrees at 7 volts, and it also has a decent torque. So I want the robot to be able to jump, that's why I went with this fastest version. Now for the carbon fiber tubes, I chose many of these because I want to do some tests. I'm not sure which diameter I'm gonna use for the legs yet. So I got 14mm diameter. This could be used for the body as well, but we'll see. Then I got, I think, 8mm diameter. So this is what I think should be enough for the legs. And I also got a 5mm diameter tubes. These could be used for the compliance mechanism I talked about. And since I'm gonna order some parts and they take 2 weeks to arrive, I'm gonna order some parts for the future videos as well. So what I want to do is, when I'm gonna test this leg, I want to build a test rig. The test rig is gonna constrain the movement of the leg in the z-axis, and I want to test if the leg can jump. So I'm gonna need some rails to guide the leg up and down, and also some aluminum extrusions to just bolt everything together and make it less likely to tip. For the test rig, I got this linear rail. I think I got this MGN9, and it comes with a card as well. It's 500 millimeters long, so it should be more than enough for the robot to jump. And to bolt this rail to something, I got 2 of these aluminum extrusions. So I got 2080, it's this long one, and I got 200 millimeters of that. So that's gonna be the base of the rig, and perpendicular to it, I'm gonna use 20 by 60 extrusion, 100 millimeters long. So this is gonna be vertical, and I'm gonna bolt the linear rail to that. I also got a bunch of other stuff which isn't as interesting, like these springs for the component mechanism, cables, new LiPo charger and stuff like that. So I'm gonna order these parts and they are gonna arrive tomorrow. Well, I'm gonna have to wait 2 weeks for them, but for you it's gonna be tomorrow. Because this is part 0 of the robot dog build. I don't want to keep you guys waiting, so I pre-recorded this, and tomorrow I'm gonna release part 1. I hope you are as excited for this project as I am. So thank you guys for watching, and I'll see you tomorrow.